Hello students, welcome to my class. In my last lecture, I was discussing about the few reasoning type questions related to this chapter, that is the theory based question, that is what is the conceptual based question you can ask, you can tell. Now next, today we are going to discuss, my last question was draw all the structure of nitrogen oxide. Do you remember? Nitrogen oxides. Draw all the structure of nitrogen oxide. That meant to say, I was talking about N2O, NO, NO2, N2O3, N2O4 and N2O5. Clear to you? Generally, it is found that this one is neutral in nature. What I am telling, this one is neutral in nature, and these are colorless gas. N2O is also known as, my friend, laughing gas. What I am telling, it is also known as laughing gas. If I talk about NO2, this is brown gas. Again I am repeating, this is brown gas, my friend. Clear to you? And this has acidic behavior. If I talk about N2O3, my friend, it is pale blue solid. Clear to you? Again I am repeating, it is pale blue solid. Again it has acidic nature, my friend. If I talk about N2O4, my friend, that is, it exists as an equilibrium with NO2. This is colorless, solid or liquid, my friend. It may exist in the solid as well as in a liquid form. If I talk about N2O5, it is, my friend, colorless, gas, liquid or solid, my friend. It exists in all three forms. If I talk about the gaseous form, it is unstable. It is unstable in gas form, my friend. Clear? But if I talk about the solid form, it exists as NO2 plus and NO3 minus. What I am writing here, that is, it exists in solid form NO2 plus and NO3 minus. Am I right, my friend? This is the case. Now, the cases, these are all the general information. Neutral in nature and colorless gas. This is called nitrous oxide. What I am telling, my friend, this is nitrous oxide, and this one is called, my friend, nitric oxide. Clear to you? Nitrous and nitric oxide, these are the colorless gases. When NH4 NO3 is heated, then the decomposition takes place and there is a formation of N2O gas. What I am telling, what are the method of preparation? When NH4 NO3 is treated at high temperature, there is a formation of N2O gas, my friend, take place. Colorless gas, that is, we can say unreactive also, and neutral to litmus, my friend. What I am telling, neutral to litmus. This is nitrous oxide. Clear to you? If I talk about NO, my friend, that is the nitric oxide. This is a gas. It is also neutral in nature and colorless gas. When copper, listen carefully, copper is treated with dilute HNO3, my friend, when copper is treated with dilute HNO3, there is a formation of NO gas take place. Again I am repeating, there is a formation of NO gas take place, and it is again neutral to litmus. If I take dilute HNO3, then NO, byproduct is CuNO3 whole twice. I am not talking about this, but if I talk about this NO2 brown gas, what I am telling my friend, this NO2, the brown gas, when, listen carefully, when copper is treated with concentrated HNO3, my friend, then we get NO2 gas. There is a difference. If we take concentrated HNO3, then we get NO2 gas. If we take dilute HNO3, there is a question from your board examination. If there is a dilute HNO3, we get nitric oxide, but if there is a concentrated HNO3, we get nitrogen dioxide. Clear to you? This is the difference. Now if anyone asks you what about the N2O3, my friend, this is pale blue solid. When NO is treated with NO2, we get, my friend, N2O3. Again I am repeating, when NO plus NO2 is treated simultaneously, we get N2O3, my friend. Now if anyone asks you what is how to form N2O4, it is in a thermodynamic equilibrium. When cooling takes place, that is, it dimerizes to form N2O4, and when heat is given, then N2O4 decomposes to give NO2. Clear, my friend? These are the this is the case, and this is, we can say, is in a dynamic equilibrium with NO2. Each and every case they exist in a dynamic equilibrium with NO2, my friend. Condensation, that is cold, N2O4, dimerization, when heat, it again gives NO2. If I talk about N2O5, my friend, when P4O10 is treated with HNO3, my friend, we get, my friend, N2O5. Again I am repeating, when P4O10 is treated with HNO3, we get N2O5 as a product. It is unstable in gaseous form, but in solid form it exists is NO2 plus and NO3 minus, my friend. This is the case of N2O5. These are the general method of preparation of nitrogen oxide. I think now you are very much familiar with this topic. This things I think look zigzag, but definitely it is helpful. When which point is so much important, mark it, this is so much important, mark it, this is so much important, this is a brown gas important thing. Now this is also an important point, and this is an important point related to this. Actually, if you go through the entire topic, entire theory, then it is impossible to memorize or understand the thing. If you have a concept, if you have the command over the techniques, then you can easily solve. Relate them. And NO, NO2. NO is, that is neutral in nature, colorless gas. NO2 brown gas. When we treat copper with dilute HNO3, we get NO. When we treat copper with concentrated HNO3, we get NO2. NO2 combines gives N2O4, and this is the thermodynamic equilibrium, my friend, with NO2. And N2O5, when P4O10 is treated with HNO3, we get N2O5, my friend. These are the cases. Now many more things we are going to add here. Listen carefully, my friend. If anyone asks you an N2O, what is the actual oxidation state of nitrogen, you will find it out. The nitrogen has +1 oxidation state. Clear to you? If anyone asks you about NO, what is the oxidation of nitrogen, is +2 oxidation state. in NO2 plus 4 oxidation state. In N2O3, what do we observe here, my friend? We observe that is nitrogen is in plus 3 oxidation state. What about N2O4? As we know, it is thermodynamic equilibrium with NO2. The oxidation state of nitrogen is plus 4, and in N2O5 the oxidation state is plus 5. So if anyone asks you to arrange them in increasing order of their acidic nature, then what will happen? Higher the oxidation state, higher is the acidic nature. So order is N2O, NO, NO2, N2O3, N2O4 and N2O5. N2O5 will have higher oxidation state, and in nitrogen case, and will have high acidic character. Am I right? Yes sir, you are absolutely. I'm moving here. Now check it out what I am telling, my friend. The thing is, if anyone asks you, draw the resonating structure, draw the resonating structure of oxides of nitrogen, then what will you do? This is the thing. Draw the resonating structure of oxides of nitrogen. Now listen carefully what will happen. If I talk about N2O, now do you have any idea how to draw the structure? Okay, let me do. Nitrogen 2 times, nitrogen, then nitrogen, and definitely there will be the oxygen. Here is oxygen. This one is the first resonating structure, and this one is the second resonating structure. Am I right? Yes sir, you are absolutely right here. That is, my friend, 2, 2, 4 and 2, 6 here. Clear to you? And here is 2, and if anyone asks you to write down, that is 2 and 2, 4, that is 2 and 2, 4. This is the resonating structure of what? Of N2O. What will happen? The migration take place, so it will contain plus sign, it will contain minus sign, and if it moves here, then this electron will move here, then again it will contain plus sign, it will contain minus, and there is a migration, there is a movement of these things. Actually in an NCERT book there is no plus and minus sign is given. That's why I am not putting the plus and minus. The actual structure is this will move here. So this one is plus sign, that is here, that there comes, if this electron pair come here and triple bond, then if it moves here, that is 2, 2, 4 and 2, 6, then we get this structure, my friend. That is the thing. Actually the thing, how to write the resonating structure, but we do not need to bother because in NCERT syllabus that the general figure is given, but we know how to proceed. That's the thing only. So what is the resonating hybrid in this case? The resonating hybrid in this case, we people can say that is NNO. This is the case, my friend. This is the resonating hybrid, NNO. Now migration take place according to the situation. Now the next one is, if anyone asks you what to draw the structure of here, that is NO. What is the resonating structure of NO? Tell me. It's is it simple? Yes. Is it simple like this? As we know, in NO there is a odd electron bond. Yes, this is an example as we have studied in class 11. As actually the 12 is 12, class 12 chemistry is a completely link with class 11 chemistry. If you have a solid command over the theory in class 11 chemistry, then you can easily solve the questions. You can easily solve the problem related to the inorganic chemistry as well as the physical chemistry also. Now there is N2, as we know in this case there is a odd electron bond. What I am telling, there is a presence of odd electron bond in NO. Yes sir, that means to say the resonating structure here can be written like this, my friend, that is N double bond O 2 2 4 and 1 5, that is 2 and 2 4. The second resonating structure can be written like this, N, that is double here 2 1 and 3, 2 2 4 2 1 and 3. Clear to you? This is the case, my friend. This is the resonating structure in case of NO, which is neutral in nature. What I am repeating, my friend, this is neutral oxide, neutral oxide, and this one is also, my friend, neutral oxide. Clear to you? Now let's move to the next one. If anyone asks you draw the structure of NO2, my friend, that is NO2. This one is, my friend, brown gas. What I'm telling, my friend, what I'm telling, this is a brown gas, and what will happen in this case, listen carefully, that is nitrogen, this one is oxygen, here is oxygen, double bond, 2 4 2 2 4 2 6. Now the next resonating structure will be like this, my friend, that is nitrogen, here oxygen, double bond, 2 and 2 4, that is 1 2 2 4 and 2 6. This is the resonating structure of NO2, my friend, and the resonance hybrid will be like this, O and O, and this is the shape we will say, that is the angular, my friend, and this will be written like this. Double bond can move in either side. This is the angular structure, NO2. Clear? I think now you can easily draw the structure N2O, NO, NO2, and now let's move to the solve the next one, that is N2O3. Now wait for a moment. Now listen carefully what I am telling. If anyone asks you to draw the structure of N2O3, my friend, now what will you do? Yes sir, we do N2O3. Clear? Nitrogen, then nitrogen, pardon, nitrogen, then nitrogen, okay, that is double bond oxygen, here is oxygen, or here we can say here double bond. Clear to you? Now completely satisfied. Nitrogen contains 2 and 3 bond, yes sir. Now it contains one lone pair of electron, here is 2 and 2 4 electron, yes, here 2 2 4 and 2 6. Now again 2 and 2 4. This is the first resonating structure. The second resonating structure actually will be like this, that is the nitrogen, nitrogen, now oxygen, double here shifting, that is double oxygen. Clear to you? Now mark here like this, 2 2 4 and 2 6, 2 and 2 4. Now here is 2 electron, 2 and 2 4. This is the resonating structure of N2O3, my friend. Am I right? Yes sir, you have. So one more thing I am going to add here, my friend. This is not a single bond. Actually the question is like this. Listen carefully. Look at what is the Lewis dot structure. You can ask me, sir, do we need to remember the structure, or we have a method to draw the structure? Yes, we do. We have a method to draw the structure. Wait for a moment. What I am telling, my friend, listen carefully. That is, as we know, nitrogen has 5 electron. Okay, so 2 2 4 and 1 5. Clear to you? Now here is also nitrogen, 2 2 4. Clear to you? Now how many oxygen is there? Now put mark here, 1 oxygen here and 2 oxygen here, like this. Okay sir? Now as we know, what will happen, oxygen has 2 2 4 and 2 6 electron in its outermost shell. Here is also 2 2 4 and 2 6. Here is also 2 2 4 and 2 6. Clear to you? Now what will happen? Listen carefully. As we know, this oxygen requires 2 electron to occupy its octets. Yes. Now this nitrogen will take 2 electron. Now nitrogen has 7, and take 1 electron. So what will happen in first nitrogen? Double bond and single bond with nitrogen. This is the first case. Now this nitrogen will take 1 electron from this, and first of all this oxygen will take 2 electron. Okay, now it occupy 8 electron. Now nitrogen will take 2 electron and 1 electron from it. Now count 2 to 4 to 6 to 8. So there is a double bond. Yes. Now look at everything possible. Now this oxygen has only 6 electron. What I am telling, this oxygen has only 6 electron, and now this nitrogen contain lone pair of electron, and it will donate this lone pair of electron and form coordinate bond, my friend. And actually this is not a single bond, my friend, this is the coordinate bond. And now write down the structure here. You can easily find out the lone pair also. This is actual rule, my friend. You do not need to remember that structure. You can create the structure if you have a, what I am telling again, if you have a command over the theory. This is coordinate bond, my friend, not a single bond. In your book it is not mentioned, but actual the structure is like this. If you follow this trend, you can solve each and every question, depends upon the situation. Clear? Now I am going to rub this part, my friend, and wait for a moment. What will happen next? Wait for a moment. The next one is, if anyone asks you to draw the structure of N2O4, again it's a simple dimeric form, my friend, dimerization, that is the thermodynamic equilibrium, and it's very easy. Put here nitrogen, yes sir, nitrogen here, down a double bond and single, and double bond and single. Am I right? Yes sir, you are absolutely right, and put the lone pair of electron. It's very simple. As again I am repeating, these are coordinate bond, my friend, not single bond. Otherwise you will get confused. 2 and 2 4, and here 2 and 2 4, 2 2 4 and 2 6. Now the second resonating structure in this case, what will happen? Just exchange take place. That is the nitrogen, this one oxygen, double bond will move here. That is oxygen, the double bond will come here. This is the case, my friend. Now put here 2 2 4 and 2 6. Yes sir, that is 2 and 2 4. Yes, 2 2 4 and 2 6, and 2 and 2 4. This is the structure of N2O4, my friend. Now the next one is, my friend, N2O5. That is the case. What I am telling, I am talking about N2O5, dinitrogen pentaoxide. Now tell me, now one more oxygen here, that is like this. Clear? 2, here is 2, here is 2, here is single. Am I right? Yes sir, you are absolutely right. Now tell me what will happen. Now again I am telling, these are coordinate linkage, otherwise you will get confused, my friend. Nitrogen cannot have 4 bonds. This is the coordinate linkage. It's better one to represent like this, and definitely that time you will not get confused. Now 2 and 2 4, 2 2 4 and 2 6, that is 2 2 4 and 2 6, and 2 and 2 4, and oxygen there is 2 bond, that is 2 and 2 4. This is a perfect structure, my friend, with representing. Now the second resonating structure of this, then it can be written like this, NOO. Clear? Now this one is like this, now double bond. Now this one is like this, now double bond, now O here. Clear to you? Now again mark 2 and 2 4, 2 2 4 2 6, 2 2 4, 2 2 4 and 2 6, then 2 and 2 4. This is the case, my friend. What I am telling, in your book actually this linkage is not there, that is why I am not mentioning. In your NCERT book that they only consider the single line, but this is a coordinate bond, my friend, and coordinate bond has symbol like this. Clear? Clear? Yes, these are the structure. I think now you have a command over these things, how to draw the structure of nitrogen oxide and nitrous oxide, nitric oxide, and nitrogen dioxide, dry nitrogen trioxide, dinitrogen tetraoxide, and dinitrogen pentaoxide. Clear, my friend? And I think it is not so much tough for you. Now the next one is the next one. Draw the structure of ammonia. What I am telling, my friend, draw the structure of ammonia. This is the question. How will you solve? Draw the structure of ammonia. As we know, we all know the structure of ammonia is like this, my friend. It contains the lone pair of electron. This is a symbol. Yes, sir. And the bond angle is around 107 degree. Okay. Now, the next one, if anyone asks you, so by example, listen carefully what I am telling. So by example that ammonia NH3 is Lewis base. Do you have this command? So by example that NH3 is Lewis base. Yes, as we know, NH3 when treated with BF3. Yes, sir. Now, what will happen? This is electron deficient compound and it will act as, my friend, Lewis acid, and it will act as, my friend, Lewis base. Clear to you? Now what will happen? There is a coordinate linkage, that is BF3, that is NH3. This adduct formation shows that it acts as a Lewis base, my friend. Now again, what will happen? The next example, Ag plus when treated with ammonia, it form complex, my friend, AgNH3 whole twice plus. That is, if I take the precipitate, that is white PPT of AgCl and treatment with NH3, then what will happen, my friend? It form soluble complex, my friend, AgNH3Cl. This shows that NH3 act as a Lewis base. If I take here Cu2 plus ion when treatment with HNO3, again it will form the soluble complex CuNH3 whole 4 2 plus. It proves that NH3, what I am telling, my friend, ammonia has the basic character. These are the very, very important questions, my friend. I'm moving here. If I write here, if I dissolve NH3 in water, what do we observe, my friend? It forms NH4OH. What does it mean? That is NH3, and water is represented like this, H plus and OH minus. That is, it is getting proton and forming NH4 plus and OH minus. Proton donor act as an acid and proton acceptor act as an base, my friend, according to Bronsted and Lowry theory. And Bronsted and Lowry theory also explain that ammonia act as an acid. In my next lecture, my friend, I will discuss the detailed information about ammonia and HNO3 nitric acid. Till then, bye bye. Thank you so much.